Okay, this is concept 11.2, and it's very similar to 11.1. In fact, if you haven't watched the 11.1 video yet, you should probably watch that. So in 11.2, what we're asked to do is we're asked to simplify all of this, solve for m, and then once we solve for m, figure out which of these is equivalent to m. And there can be more than one, just to add a little wrinkle. So this is not like the old test days where you have A, B, C, D, and you have one right answer, and that's it. Now there can be more than one of these that fit because there are several of those that are actually equivalent to each other once they're simplified. So we're going to start out, and the very first thing we're going to do, this probably looks awfully familiar, we're going to change this into an addition problem. Everything into addition. And we're going to go through, and everywhere we've got negatives, we're going to highlight those negatives so we really keep track of that. Okay, we're going to distribute now, and I'm going to use this blue color every time I'm distributing for the x's. And I'm going to use, let's make it brown every time I'm distributing the ones. Now, the reason I'm doing this is it's going to help me keep track of which things I can combine. You can do the same thing by drawing lines under them or coloring them with your highlighter if that helps. So 3 times 12x is 36x. 3 times negative 7 is negative 21. Negative 2 times 6x is negative 12x. Notice everything's addition. And negative 2 times negative 3 is positive 6. On the other side, 3 times 5x is 15x, 3 times 4 is 12, and we bring down the 3m. There's nothing to combine with the 3m. It's not in the parentheses, so it does not get multiplied by this 3 in the front. All right, our next step is to start combining things. So I've got 36x's and negative 12x's. I'm going to work down here on the bottom part of my paper. I've got 36x plus negative 12x. 36 positives, 12 negatives. That's going to create 12 zero pairs. Anytime I'm combining positives and negatives, I want to keep in mind this zero pairs. Things cancel out. You might think, well, you know what? Do I really have to put that down? You don't. If you can do it without, you don't. I still find it useful. And I've noticed the papers of the students who do the best at this, many of them still write down the idea of the zero pairs. So 36 positives, 12 negatives. These 12 negatives cancel out 12 of those positives, leaving 24 positive x. All right, plus, everything's going to be addition. I had negative 21, and I'm adding positive 6. This, again, is going to create zero pairs, negatives and positives. It's going to create 6 zero pairs, which means these 6 positives will cancel out 6 of the negatives, leaving 15 negatives. And on the other side, nothing to combine, so I just bring it down. All right, time to get m by itself. Remember, we're trying to get m by itself, and so we're going to need to move the 15x and the 12 out of this side. So I'm going to add a negative 15x to both sides. So here we go, negative 15x. 15 zero pairs, because this is negative, and the 24 is a positive, so these 15 negatives cancel out 15 of the positives, and they leave 9 of the positives, 9x. I also have to get rid of this 12, so I'm going to add a negative 12 to both sides. Notice 15 negatives and 12 more negatives. Those will get combined. They're not going to cancel out. They're going to get together. So 15 negatives and 12 negatives give me 27 negatives. All of that equals the 3m that's left. It didn't get canceled. So these canceled each other, these canceled each other, 3m left over. Final step. We're going to divide everything by 3 because it's the coefficient of m. And one more time, up here we're trying to solve for m. 9x divided by 3, 3x. Negative 27 divided by 3 plus negative 9, all of that equals m. This is what we're looking for now over there. So let's write that down. We're looking for things that are equivalent to 3x plus negative 9 or 3x minus 9. So now we go through A, B, C, and D, and we simplify them. Simplify A, 3 times x, 3x, 3 times 3, 9, 3x plus 9, 3x plus negative 9, not the same thing. Not the same thing. All right, let's change this to addition of a negative before we simplify it. 3 times x, 3x. 3 times negative 3, that's plus negative 9, and that's a yes. That is equivalent. 3x plus negative 9, 3x plus negative 9. 1/3. Now don't get thrown off by the fractions. 1/3 of 9x. So you can do it a couple ways. We can go down here. 1/3 times 9. That's 9 over 1. Simplify it out. 3 goes into 3 once. 3 goes into 9 3 times. So 1/3 times 9x is 3x, 1/3 of 9. 1/3 of negative 27. Here was our plus and negative. 1/3 of negative 27. Well, 1/3 of 27 is 9. So 1/3 of negative 27 is negative 9. 3x plus negative 9. That's another yes. And then the last one, 1/3 of 27. 9x plus, all right, here's our plus the negative, plus 1/3 of negative 9 is negative 3. That is a no. Our correct answers are B and C. These types of problems, you're going to see more of these where on these types of problems there are multiple correct answers. Okay, I'm going to scroll the screen down. I'm going to show you another one of these problems. I'd like you to pause the video, try to work the problem for yourself, and then start the video up, check your answer. So here is our problem. Go ahead, pause the video, and then start it up, and we'll go through this one together. All right. So you can fast forward to the end if you want to check your answer now, or if you need to watch the steps, watch a little bit of the steps, then pause, try to work the problem out, then fast forward to the end. Do whatever works for you, and if you need to replay it, replay it. This is the advantage. You get to listen to my voice as many times as you feel like you need to, or as little as you feel like you need to. So first step, we're going to go through and we're going to make this whole problem into addition. Everywhere we see, oops, not that one though. Everywhere we see a negative, a subtraction, excuse me, we're going to make it adding a negative. Then we're going to go back, and the more I do this, the more I like it. We're going to go back and we're going to highlight every one of these negatives, including this negative 2x. We didn't change anything, including this negative 4 and this negative 2x. So it draws, when we see those highlights, it draws our attention to the fact I need to make sure to keep track of the negatives. Okay, let's go through and distribute. 4 times 6x is 24x. 4 times negative 10 is negative 40. Negative 8 times negative 2x is plus 16x. Negative 8 times negative 1 plus 8. On the other side, negative 4 times negative 2x, positive 8x. Negative 4 times negative 4, positive 16, plus 8m. We can combine 24x and 16x. Here, no zero pairs. They're both positive, so there are no zero pairs on this, and we get 40x. We can combine negative 40 and positive 8, the negative 40, the positive 8. This will give us 8 zero pairs. The 8 positives will cancel out 8 of the negatives. So 40 minus 8 is going to be 32, so we've got negative 32 left, and that equals 8x plus 16 plus 8m. Now it's time to go ahead and get the m by itself. Remember, we're looking to get this m alone, get m alone, get m alone. That's our goal. So we are going to add negative 8x to both sides. We have to cancel out. This is all stuff you've done before, so be confident. So 40x plus negative 8x, 32x. We also need to get rid of the 16, so we're going to add a negative 16. Add a negative 16. These aren't going to cancel. They're going to combine. 32 negatives, 16 negatives. We get plus negative 48. All of that equals our 8m. Final step, get m by itself. We divide everything by 8. And I'm going to, oops, well, that didn't work very well, did it? Okay, I think I fixed that. There we go. I'm just going to shrink these down a little bit, my zero pairs, and move them out of the way so that there's room to finish this problem up. So we have 32x divided by 8. That's 4x plus. We have negative 48 divided by 8. That is negative 6. And that equals m. And this is what we're looking for over here. So let's bring that over here. We're looking for things that are equivalent to 4x plus negative 6 or 4x minus 6. Those both mean the same thing. So now we're going to go through and we're going to solve these. Let's make this adding an opposite, adding a negative. 4x, good so far. 4 times negative 2 is plus negative 8. Nope, we need plus negative 6. Doesn't work. Our next one, again, we're going to make it adding the opposite, adding a negative. 2 times 2x, 4x. 2 times negative 3 plus negative 6. Yes, this is a solution. We like B. Letter C. Again, let's make sure we make that adding the opposite. I'm going to come down to D, and I'm going to do it right now just because I know I have to do it eventually. 2 times 4x, 8x. 2 times negative 3 plus negative 6. We have the plus negative 6, but we have an 8x instead of a 4x. Not a solution. And finally, letter D. 1/4 of 16. 1/4 times 16. 4 goes into 4 once, 4 goes into 16 4 times. 1/4 of 16, 4x, plus 1/4 of 24, negative 24. That would be a negative 6. 4x plus negative 6, that's what we're hunting for. So that's a yes. We like letters B and D. Those would be our correct answers. Okay, so go back and look through this as much as you need to. This is also showing up on the Practice Plus test for week 11, so you have another chance to work on that. This is all work you can do. It's all work you've seen before. It's just packaged a little differently. So don't think of it as something brand new. Think of it as something you've done before, and they're just showing it to you in a new way. Okay, if you have questions, be sure you bring them to class.